Okay. I guess I can continue. Thank you, Nicholas, for your input here. And now I can actually share my screen again. Yeah, I'm gonna actually show you some early results we got from testing COALA in the field. And basically the lessons we learned from implementing it and testing it, not only with expert users, but also with more layman users, like more like students. And you might ask me why, but I hope I will answer the question by the end of this presentation. So for those people who just joined, I still have the same 2 slides in the beginning, just to make sure that everybody's following, the ones I just showed in the introduction, explaining again the context of the factory of today, that we have a lot of technology on the shop floor, a lot of smart machines, but still a lot of manual work and a declining workforce. That's what you need to keep from here. We need to also train and onboard the new operators that join us, and that's also where the COALA is particularly effective, and we hope it is, and how to extract asset knowledge and knowledge that is hard to collect and organize, and particularly helping with agile manufacturing, right? And contributing to this paradigm shift from Industry 4 to Industry 5, which is all about placing the human in the center. That was the 2 introduction slides I had before, but I hope just the new people join now are on board with it. So what can the COALA Cognitive Assistant do, right? You will see probably often in this presentation using the CA as an acronym for conversational or cognitive assistant. So the idea is that it converses with experts and collects knowledge from them in order to teach the novice people. As I mentioned before in the introduction, it is linked to APIs, application programming interfaces, that they are available on the shop floor from smart machines and sensors. So, and gets real-time information from the production line. For example, you can get how many units have been produced. You can also get how many faulty products have been produced, if they were overfull or underfull, and make some nice overviews and provide recommendations based on that. But at the same time, the most important thing is can detect when things go well, because when things go bad, everybody can see that, right? So when things go well, it can notify the user, and basically the user in this case is the operator on the production line, and collect information from them about what they did right, what configurations they had, or what type of material they used, or what type of techniques they employed, and so on. And collect that knowledge that typically is hard to get. But if you get on the spot, then you have a chance to record it and store it in what we call a knowledge graph or a knowledge base, right? How do we do that? The COALA supports both mobile, web, and desktop interfaces. And in this case, we typically use the mobile one at the factory. And as we said before, it supports also text-based and voice-based interaction. You can type text and you can talk to it either, right? Depending on your what you want to do or your task. If your hands are busy, you might opt in for voice interaction. If there is a lot of noise, then maybe it's better for you to use the text-based approach. The important thing here is that we, so far in COALA, we're approaching to the end of the project. We have been always designing and co-designing with operators to complement human capacities. So we never thought that we are designing a product or a service or a system that will take the people out of the loop, and we plan to replace them by whatever fashion. The idea here is to augment the capacities of the operator by pairing them with intelligent product system and services such as the COALA Assistant. In this particular presentation, we have come up with a simulation architecture that at the same time you can see basically what the COALA is comprised of. Is this box here. And the simulation was necessary because you're going to test outside the narrow boundaries of the factory, right? You're going to test with more people just to see if the advisor or the assistant, cognitive assistant, the COALA, is able to help someone operate something. That's the idea here. So for this, we create a simulation, like a fake machine that would run into your web interface, and you could be using the COALA next to that, and the architecture of COALA, of course, is the one you see here, in order to help you, like a puzzle, solve the problem. The simulation was actually as close as possible to the real production line of particular machinery they have in Diversi. And the COALA, of course, assistant was equipped with the knowledge that you need to know in order to operate that production line. And in this particular presentation, in that version, we tested with a lot of diverse people. We have five features, and I will just show you demo or like a screen capture on these five first ones, because the other three are products of these five primary features, such as live settings recommendation, issue handling, FAQs, frequently asked questions, product settings and knowledge sharing, and production statistics. And without further ado, just show you a little demo or screenshots we got and video from operating the COALA Cognitive Assistant in that particular context. So the first one is live settings recommendation. So as you can see here, this is the flow of the dialogue you have with the system, the COALA system. A user or operator, in this case, asks for real-time speed advice. Then the COALA connects to the API of the weight checker. When the products go through the production line, they get checked by machine, gets the readings from a database and generates sets of values based on current speed, weight, and then delta to historic max. And then basically COALA requests classification explanation from the Y engine in order to provide a particular recommendation. So the moment the user gets the recommendation, he can ask why. And that Y engine that Nicholas was actually referring to can provide you a proper explanation as to why the specific recommendation is actually offered, based again on the features extracted in the database and a machine learning model that is explainable. That's the simple recommendation you can get by asking what you can do better. The other feature we have, and I can actually play a video here, which is just the interaction with the user. As you can see, is actually in Dutch for those who haven't realized yet, because the Diversi in Enschede is a Dutch factory, so we developed specifically for Dutch support in this case. Don't ask me to translate what's going on here because my Dutch is not that strong yet. But what you can see it's happening is we have two ways of interaction. The user asks to record an issue solution. So for example, the operator sees a problem on the production line and says, I have the following issue to report. Then the COALA requests additional information. The user provides additional information and then stores that in a knowledge base, potentially with a solution. Sometimes without the solution. If there's without the solution, then that is forwarded to as a ticket and somebody handles that. But potentially with solution, let's assume it's coming from an experienced operator. On the second phase or the second stage, there's imagine a novice operator that requests help about an issue. Then the COALA asks the error code for the specific output of a machine. You put the error code in. As an operator, the COALA queries the database, the Neo4j knowledge base. We also have a new component here that uses the GPT-4 API. I will revisit this in the last slide I have in this deck, and I will reconnect with what Nicholas was actually mentioning before about all the considerations we have there. But finally, you get a well-defined and refined response back to the user with the help of GPT-4 here. So we're using also GPT-4 in our workflows with COALA. The next feature we have is FAQ, like frequently asked questions. It's a simple model. You just ask a question, general question, and given that is in the sphere of knowledge or the knowledge base of COALA, you get an answer. So not much to see here, just random question and answer, as long as it's within the knowledge base of the COALA about the particular problem. You get multimedia support, you get pictures, you get sounds, you get videos, whatever depending on what is in the knowledge base and what is provided by the end user, the factory management in this case. The third one we have is product settings knowledge sharing. So a user asks to save product settings. You might be able to come up with new settings, basically, about a specific production line and specific type of product produced in that particular production line. Speaking again about agile manufacturing, where production changes within half an hour. Like in this particular hour, they produce product A, and then they have to reconfigure the entire machine to produce product B. So that's particularly helpful for not doing mistakes. You can actually teach the COALA in stage one how to, if you have new production settings, and then learn from COALA if you're a novice person, about how to configure properly a production line in case of change in production in this case. Again, that support here for our that's end user in the Enschede. Then we have product settings and knowledge setting. I covered it, I think, and production statistics. In this case, we have someone or operator on the production line that might need to get a glimpse of how it's going in terms of production statistics. Are we going above the limit or below the limit in terms of weight? Are we producing too many faulty products and so on? So what happens is that you can ask the COALA, the advisor here, the cognitive advisor or assistant, to provide some sort of visual representation of the production that is currently taking place. And again, the COALA connects to the database, the weight checker, any kind of calculation that happens in the backend to get specific time frame and visualize for the operator a specific variable that was requested, in this case, the weight over the last hour, for example. And that's an easy way to visualize what's going on the production line. That's also part of what the COALA advisor does. In this case, we did some early testing, as I mentioned before. This paper, by the way, it was published 2 months ago in Intelligent User Interface in Sydney. It's an ACM conference. And what the setup we had a user, which could be an operator, could be a student, could be someone who knows about technology or doesn't know about technology. And it had on one side the cognitive advisor or assistant, the COALA, basically on one side. On the other side, had the simulation, because this interface you see here, these two views, that simulate as close as possible the weight checking machine at the production line of Diversi in Enschede in the Netherlands. And it's like a puzzle. So you try to basically produce specific canisters by entering specific configurations, like you do with a real machine on the shop floor. And you were able to basically produce virtually fill-in cans. And as an ally in that task, you had COALA next to you, and that's what user was interacting with. Both with the COALA on the left and on the right was actually the simulation. So you use the cognitive assistant as a way to solve the problem, which was produce X amount of cans, for example. The main research questions we had here is, how does prior training, because we offer them some training, yes and no, like half of the people, we split them equally, A/B testing. Prior training affect user performance, perceived workload, user experience, and perceived usability when using the COALA Cognitive Assistant. How does context expertise? The context expertise in this point refers to being a student, being an actual operator, being someone who has nothing to do with the factory, and how these different profiles of users perceive the workload imposed by the simulation and the advisor, user experience, perceived usability, and so on. And finally, the modality of interaction with another independent variable, like how does it feel in terms of performance, perceived workload, or user experience? How is it to interact with advisor on a laptop versus a smartphone, for example, or something like that, like different variables to test here. We had 8 knowledge sharing tasks. It took 10-minute max of the time. We had the groups I mentioned before, training, instructional video versus not instructional video, expertise, it's an expert versus non-expert, modality, a smartphone versus a laptop that you could use the software and the cognitive assistant. And in total, we have 83 people. This is the breakdown you can see here. Of those 83 people, we had 12 employees, actual factory employees. The rest were researchers, external HCI researchers, 16, internal ones from TU Delft, 18 people. And we also have design master students, 37 of those from the 83 total. Quantitative or qualitative measures, you had performance in terms of task completion. Were they able to achieve or not? Yes or no? Task completion times, how long did they take to achieve the task, to fulfill the task, 8 in total number. How many turns they took with the advisor, how many times they talked with the advisor, and specific questionnaires, which is about workload, cognitive workload, user experience, and system usability. And this is basically how it looked like on during the train round that half of the people got, explaining them how to use the simulation. And we also have some exit in questionnaire and digital post-its that we collected on a Miro board about the cognitive assistant. The results are interesting. We had significant differences basically between untrained and trained people. So those who were trained, they perceived the advisor or the assistant far more cognitively heavy for some reason. Those who actually were trained, they gave less usability score than those who actually were untrained. And those who received the training in the beginning, they indicated lower user experience. So what we get from here is that if you give them a training, perhaps you actually lower your perceived quality metrics in terms of user experience, workload, and usability. Then we had some summative results for RQ research question 2 and 3. We actually saw that the workers on the factory, operators, took longer to complete the tasks, which you would expect the opposite from if there's an expert should be able to do it faster. Then we also saw that the operators graded the assistant as more usable than the students and the researchers. And also we saw that the workers gave far better scores in terms of experience than the students and the people who had nothing to do with the factory, by the way. But we found no significant effects between smartphone and laptop. That was the findings we had. We did a final content analysis here to get all the comments we were able to collect on the Miro board, on exit interviews with the people, the participants of the study, 83 in total. And we found that we had comments on the limited abilities of the natural language understanding when it comes to divergent phrasing, resulting in conversational breakdown some of the times. 4 participants found the applied repair strategy and restart option to recover from a breakdown a bit ineffective. 5 of the participants wished they could talk to the assistant by using keywords instead of complete sentences. So they liked a lot the keywords and shortcuts instead of phrasing a whole sentence either by talking or basically typing in this case. Participants indicated interest in the prospect of using the cognitive assistant. They were generally positive. 1 worker or operator asked when will be able to use it on the App Store. Basically, they want to download from the App Store. The ease of use and quick access to information is great. 7 participants voiced concerns regarding safeguarding the quality of acquired knowledge and how to select the most appropriate recommendation as the knowledge base grows. So they were concerned about the fact that anybody in their perspective could input knowledge and how this knowledge gets tested and goes in database, right? So that's something we already have tackled in COALA anyway. 11 participants stated that the cognitive assistant might not be realistic for complex enough to be adapted in manufacturing use case. They were a bit skeptical about how able this system will be to support the complex use case of manufacturing. And 1 participant seemed to say that it works well for the prescribed tasks on the whole, hard to relate this to real life on the floor. So they were a bit hesitant about how this would be actually in the real life scenarios on the shop floor. And that's it, basically the content analysis here. We were able to extract design guidelines based on the results I just showed you. You should, in this case of deploying a cognitive assistant, you should deprioritize training when users are technologically adept. If the users know how to use a mobile phone, if the users know how to click on a questionnaire or use web interfaces, you don't need to train them, right? Just get to the point directly. You should test with diverse user groups to account for vested interest and positive bias. So what we observe here is that the operators, they gave really good ratings. However, the people that had nothing to do with factories gave very bad ratings. So the truth is somewhere in the middle, because the operators might be simply biased towards being more positive against the COALA advisor because they recognize the fact that we're trying to help them. So they kind of reward you with better ratings or better question responses. That's why you should always pick a diverse group to set your product, in this case, the advisor. The intent shortcuts having keywords, basically, they were more effective than having different modality types. Whenever you have a whenever you have a conversational breakdown, it's always important to salvage it. Whenever there was like the advisor could not understand what the user wanted, it was actually responding with, "I'm sorry, I don't understand. This is perhaps one of these three things you would like to do," and it has keywords. This was very well perceived by all the user group. And finally, use suggested response to streamline interaction. So always when you have shortcuts, it helps the people move on to the faster without needing to speak or basically type. That was very well perceived by the people, be it experts or non-experts. With that, we have ethical considerations we discussed. Like I think Nicholas already touched upon them. The operators may gradually become overly dependent on the cognitive assistant. We're aware about that. So we are actually employing strategies such as open-ended questions to spark critical thinking. You can basically have the advisor asking you open-ended questions just out of the blue, just to make your brain work in a way on the production line and not blindly rely on it. The management could, for example, misuse the real-time data to invade operators' privacy. That's a big privacy concern here. Now, on that, we have that policies protect workers' privacy and rights are definitely necessary in Industry 5.0. We always strive for GDPR compliance, and we always have data management plans when it comes to deploying this type of solutions. And one also point that Nicholas touched upon also was who owns the knowledge, the management or the operators, right? The suggestion we have here is to treat it as IP, intellectual property, and I would say track who produces the knowledge of the operators and treat that person as co-inventor, for example. Another thing that one of our partner factories does is introduce reciprocal policies, such as rewards for best production tip of the month. So, for example, recognize the value of the operator inputting knowledge into the system and make that a bright example. Limitations, definitely one does not simply deploy prototypes in the factories. It's very hard to deploy. We're actually deploying at the moment with the different follow-up studies we have. And the study took place mostly in the lab. They did not share their own knowledge, but they followed the prescribed task. We use a simulation instead of actual production line equipment, but it's not easy to have so many people receiving advice from the COALA and applying the advice on the actual machine while it's producing products, because they will probably break it or they will stop the production. That was the reason for getting these big numbers. We learned a lot and we move on to the new evaluation we're doing at the moment. The elder participants were mostly operators. That's the main thing. And they were not technologically adept. So the people in the factories do not necessarily know how to handle this technology. So we need to basically help those who don't know how to use technology, help the technology reach them better. But this is the reality in the factories, and this is why we recruit diverse participants, because we want the balance, basically. We also run the study in batches and in group settings, so maybe there was also some influences there. And with this, I think I'm over time, and I have to finish. This is the last slide. Hearing to what Nicholas said before about large language models and ChatGPT, we fully take this into account, but we could not turn a blind eye to the fact that large language models are turning the tide in what has to do with knowledge management and chatbots in general and intelligent assistants. So we took the extra step here, and we're developing at the moment an LLM-powered COALA Cognitive Assistant. And the benefits are so many. I just list a few of them here, and we just show them appearing just by testing this cognitive assistant with a few operators already. We have simplified software architecture. We don't have so many different APIs that we have to connect to, and so different frameworks that you update one and the other breaks. They are rapidly deployable. We just request a few PDFs. We upload them to the system, semantic embedding, and then prompt engineering, and you have like an assistant ready to be used. Powerful and openly available models. You can see all these models at the moment we're testing. They're openly available. They're not just ChatGPT only. You can actually deploy them locally. Out of the box multilingual support, you can just change a variable in the code, and the whole knowledge base changes languages without you needing to provide additional PDFs in different languages. Just a flip of a switch, and then the knowledge base becomes multilingual on the spot. Out of the box logic checks. whenever there's new knowledge being inputted into the system, the LLM provides the functionality to check the logic behind the argument, like, or behind the new procedure you're proposing. For example, if you say, I have new settings to report, and I would like to increase the temperature because the pressure was too high. That would not go through the LLM. You say if you increase the temperature, the pressure will also increase. So if you want to drop the pressure, you should probably reduce the temperature. So this type of very easy logic checks, they are out of the box available with LLMs. They can be GDPR compliant, whether we believe it or not, that's the truth, as long as they're locally hosted. So you can download these models, pre-trained models from Hugging Face, and you can actually deploy them in a specific hardware you have in your premises, and they can run there locally. However, this requires significant hardware investment. At the moment, I don't think we have the funds in the COALA project to buy something really big. We tried to buy some small PCs to try this in the COALA. It works well, but it doesn't scale. We need a proper big server machine. I managed to convince our head, and he bought something. I bought a big GPU server with department money, and we can actually check how well COALA does there. But this is something we're trying at the moment. There's virtually no conversation breakdowns. It always replies to you, always tries to understand what you say. It never would say to you, I don't understand what you say. That you don't have that with LLMs. There is no cold start problem. The moment you throw in a PDF in the knowledge base, it starts basically providing you answers as long as you answer within you ask within that what is on the PDF, and it gives traceable answers. If you ask why, it gives you the segment in the PDF that has the answer. So that's why we think it's very promising to invest in the LLM side of cognitive assistant here in COALA. And we're doing so at the moment, and we have a new assistant that we will show results at the end of the review meeting. We're still collecting responses. And I think I'm way over, so I have to stop. Thank you for your patience. Yeah.